So we're looking at page 16 in the Unit P packet. It's the vectors in a plane section. This is firmly in the category of maybe, maybe not, in terms of whether or not you've seen this before. Physics students definitely, math students maybe. It's a pre-calc topic, but it's often one that's skipped. So here is your crash course on basic vectors. All right. So a vector is a quantity that has both magnitude and direction. So the first little example here, just sketching a vector in a plane that has an initial point of 1, 1 and a terminal point of 4, 5. So I'm just going to eyeball it. Here's 1, 1. Call that point P. And 2, 3, 4, 2, 3, 4, 5. Oh, that's pretty terrible in terms of the spacing, but that's kind of not the point of things here. 4, 5. That would be point Q. If you draw a line segment connecting those 2 points, then in geometric terms, that's just a line segment. But what if you were to take that line segment and pin one of the points to the origin? I didn't mean to take that little tick mark along for the ride, but that's all right. Get out of here, little tick mark. All right, so by pinning it to the, oh, actually, I should have copied it. All right, so taking that line segment, pinning one of the points to the origin, and indicating not only the length, all right, so the length of the segment, gives the magnitude, but also we need direction. All right, the arrow indicates the direction. All right, but there's so much more to it than that. All right, we would call this vector, PQ, with the little notation, little arrow notation on the top. All right, what a lot of people will do is they'll just put a single, like half of an arrow on the top, and that's perfectly fine, all right, either way. All right, so then the big question would be, well, how do we identify this vector PQ? And also, what are those oh so many other things that come into play when dealing with vectors? Well, those oh so many other things would be, well, an arrow doesn't tell us anything. Well, that's not true. It tells us plenty. It just doesn't tell us anything numerically. All right. What we would want is something like, oh, what about this angle here? Angle off the horizontal. Yeah, that's meaningful. All right. We'll learn how to figure all that stuff out. All right. But for now, in order to figure out the measure of the vector itself, what we would do is we would translate point Q based off of the number of steps it takes for point P to get back to the origin. So for point P to get back to the origin, it would have to take 1 step down and 1 step over to the left specifically. So we would do the same thing for point Q. And I know I'm going to be pulling over a lot of extra fluff here, so just kind of deal with it for a sec. Till well, we'll live with it. It's not as terrible. All right. So that movement would give us this new endpoint here. That new endpoint is how we so we can get PQ simply, rather than showing the graphical values, we can get it by finding the difference between corresponding components. So I could find, using vector notation, which is this triangular looking bracket, 4 minus 1, comma, 5 minus 2, 5 minus 1. So in this case, we get 3, 4. And so that would be vector PQ. And we use that triangular notation in order to make it obvious that we're talking about a vector rather than just a simple coordinate. All right. We could also figure out the magnitude, because if we're looking for the length, you know, I'm kind of getting ahead of myself here, but if we're looking for the length of a line segment, we can rely on ordinary geometry. So if we know that there's a distance of 3 horizontally and a distance of 4 vertically, 3, 4, 5 is a Pythagorean triple, then you could figure out the magnitude of that that vector. And just so, you know, like I said, I'm stealing my own thunder a little bit, but this notation here, the double absolute value, that represents magnitude. So in this case, it would be 5. All right, so you're just using the Pythagorean theorem. So this means the magnitude of vector PQ. All right, so the definition, just kind of address that. The scalars, x and y, are called the components. And so each one of those components gives us an indication of direction. So we have the follow-up example, like the official example related to this, without me stealing my own thunder repeatedly. Express vector v with initial point -2, 2 and terminal point 1, 2 in component form. All right, so the component form would be, again, taking your x components, so in this case 1 minus -2, and your y components, 2 minus -2. All right, might as well highlight. I'm in a highlighting frame of mind right now. So 1 minus -2 is 3. 2 minus -2 is 4. And again, if you needed to find the magnitude, you can do that. We did it graphically, but if you really think about it, there's ways to do it that don't involve creating the graph. All right, they're calling this vector v, so that's what we'll call it. All right, and we're going to learn about vector operations, which is really fairly simple when it comes to addition and subtraction, and also something called scalar multiplication. That's when you take a constant value and multiply it by a vector. So you're scaling the vector up or you're scaling it down. You know, so if I multiply a vector by 2, I'm doubling the length of the vector. If I multiply it by half, I'm cutting the length of the vector in half. All right, so that's, I'm sorry, not the length. That was, almost put a hex on the whole thing. No, so what you're doing is you're cutting the components in half, or you're doubling the components, but it does have a doubling effect. Now the magnitude will not be doubled, but we'll get to that at some later point. All right, so m plus p is really just a matter of taking your vector m, which is 5, -7, and adding to it -1, 3. So, force a habit. So what do? Well, you copy and paste. Kind of. So I don't need, honestly, it's one of those things where it probably would have been easier for me to just rewrite. So delete. So I'm just going to add the individual components. After all that, sometimes we live and we learn. In theory, we should always live and learn, but it doesn't always happen. All right, so we're adding each component to each other component and going from there. All right, lesson learned. I'll just use my highlighter approach from now on. So 7 plus 3, -7 plus 3. And so combine your terms, and this is something in theory you should be able to do in your head. I was just getting... So then for number 2, I'm going to double, you know, you can use a little bit more of an intuitive approach. That's the idea. So I'm going to double my m, which will give me 10, negative 14. I'm going to triple my n, which is going to give me 0, 12. And then I'm going to negate my negative 1, 3. So if I negate it, that gives me 1, negative 3. And then just add them all up. And I'd be looking at 11, comma, negative 14 plus 12 is negative 2. Negative